Hi, welcome to question 3 of the Leaving Cert Ordinary Level 2025 Paper 1. So, as always, if you want to copy these notes, just send me an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. So, question 3 here, I don't know what the marks are for each part. The marking scheme isn't published yet, but we'll read through it. It says Ricky is buying protein bars. The cost of a single protein bar is €3.30. A shop has the following two special offers. Offer A, you get 3 bars for the price of 2 bars, or offer B, you get 12 packs of the same bar for $29.99. Which offer is cheaper per bar? Use calculations to support your answer. And you have an offer A option and an offer B option. So the answer, okay, we've worked our way through offer A. Well, 1 bar is equal to 330. So 2 bars, twice that, is equal to 660. That means that 3 bars, okay, because one of them is free, costs 660. Now, the 12-pack offer, okay, is 12 bars for $29.99. Now, to find out what 1 bar is, we divide by 12. If you do it to one side, you have to do it to the other. And that's a simple way to keep the algebra, clear. That gives us an answer of 1 bar is equal to €2.49 effectively. Now, you could round it, but an early rounding could affect the answer. So try to avoid that. That means that 3 bars is equal to 750. So offer A is the better offer. Hope that makes sense. Okay, it's not too bad a question, as long as you don't get overwhelmed by the amount of words. Okay. Now, part B says solve the inequality for x is an element of R. That means that your x value is a real number, so it can be any number. It could be a fraction, decimal, it could be a whole number, it could be an integer, whatever. Okay. Don't really worry about that terminology as long as you can solve the inequality, which is dealt with just like an equal, and there's only one situation where it's different, and that actually happens in this question. I always like to write out the statement again, and then I want x on one side, and I want all the numbers on the other, and I want to end up with 1x inequality, whatever. So I'm going to get rid of this 4 by taking 4 away. If I do that on the left, I have to do the exact same thing on the right. Okay, for a lot of people, that's okay. They have faster ways of doing algebra, but it can be a sticking block for a lot of people. And if you do the simple thing, just deal one thing at a time, do whatever you need to do, the opposite thing too to get rid of it. And as long as you make sure you do the exact same thing to the far side, you'll never be far wrong. Okay, take your time. Now, the consequence of that is that the 4s cancel. Okay, and on the far side, -8, take away 4. Use the calculator if you need to. Okay, actually, I seem to have made a mistake here. Okay, apologies for that. I just paused the video there and fixed that error. Okay, so then 2x is greater than or equal to 6x, take away 12. Now, if I keep going on, okay, now I'm going to try get rid of the 6x here on the right-hand side. And again, I just take away 6x, do the opposite thing to it. If I do it to one side, I have to do the same thing to the other side. And that brings me on 2x take away 6x is -4x is greater than or equal to -12. Now here, the interesting thing with inequality happens. If I multiply or divide across by a negative number, the inequality has to change direction. Now I could just swap these either side, okay, in order to get rid of the minuses, and then you wouldn't need to swap the inequality. It would end up being 4x is less than or equal to 12, okay? But since I'm doing it the other way, I'm going to divide both sides by -4 because I want to get rid of the -4 in front of the x. So I'm doing the opposite to it. -4 divided by -4 is +1. On the far side, -12 divided by -4 is +3. Okay, but you'll notice there the inequality has changed direction. Okay, and that means my answer is correct. If I test this with a few values and put it back into my original inequality, it should be satisfied. Okay, and that's it. My answer is a real number because a positive whole number is a real number. And that's it. Now, part C here has a statement k times t equals 12, where k and t are elements of z. That just means they're a whole number, but they can be positive or negative. Okay, and it says write down a possible value of k and the corresponding value of t. Now, the first one that I come to in my head, I'd be thinking of two numbers that multiply to give 12. It could be 6 times 2, it could be 3 times 4, it could be 4 times 3, it could be -3 times -4. Okay. So I'm going with 3 times 4 because it's easy, okay? And then I end up just stating it, okay, just so it's clear to the examiner what you're declaring as your answer. Now, part 2 says use your values for k and t from part C1, so these two values here, to find the value of b in the equation below. So you're given this kind of algebraic statement, and all you have to do is swap out the k and the t with the numbers you identified in part 1, okay? Even if they were wrong, they'll still be accepted as fully correct here. Now that ends up with a 2-term bracket multiplied by a 2-term bracket. Now you don't really need what's on the right hand side, but I just like to be consistent. I need to simplify this multiplication. So I do that by writing one bracket out twice. Now I'm choosing the first one, write the first bracket out twice. Then the first term of the second bracket multiplies into the first bracket here. The second term of the second bracket multiplies in here. And then I just go left to right, okay, and I get x times x is x squared, x times 3 is 3x, 4 times x is 4x, and then 4 times 3 is 12. Now I'm almost there. If I just combine these x terms, I end up with x squared plus 7x, 3x plus 4x is 7x. The 12 doesn't change. My b value corresponds here, and that's the answer. So not a terrible question, just can be off-putting. When people see this terminology, it often puts them off. You can effectively ignore it, okay? It's just being mathematically correct, and hopefully you'll have success. Now, that's the end of question 3, and as always, if you want to copy these notes, send me an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.